All right, let's do some exercises on acceleration and average acceleration. So the first exercise here, the position x of a particle varies with time t as this. The acceleration at time t of the particle will be 0 when t is equal to how much? So we have to find first the acceleration of the particle, and then we, according to the question here, the acceleration will be 0. That means we will equate that equation of the acceleration to 0, and from there we'll find the value of t. Okay, so the position is already given as x is equal to at square minus bt cube. So therefore, first of all, we'll have to find the velocity. Velocity here is dx dt. dx dt. dx dt. Differentiate this, you'll get 2t. Okay, let me not do the shortcut. So differentiate d dt of at square minus bt cube. So here you differentiate d dt of at square minus d dt of bt cube. Okay, so you get v is equal to a here. I can take this a outside. Then differentiation of t square, d dt of t square, minus, I can take the b outside, differentiation of d dt of t cube. So d dt of t square, I will get 2t. So you have 2ta. This will give us 3t square. 3t square b. Okay, so that is the velocity. Therefore, acceleration, let me take it with capital A because already small a is taken. So acceleration is dv dt, rate of change of velocity. So I have to differentiate this. So differentiating this, d dt of 2ta minus d dt of 3t square b. So this becomes, you'll get here 2a is a constant, so d dt of t, that will be 1. So from here you'll get 2a minus, then 3b is a constant, I take it out, d dt of t square, that will be 2t. So I'll get 3b and inside bracket 2t. So this will be 2a minus 6 bt. This is the expression for the acceleration. Okay. Now the question says here the acceleration, at what time will the acceleration will be 0? So what we need to do is we will just equate this to 0 and then we'll find the value of t. All right, so let me do that in the next page. So therefore, a is equal to 0, which means that 2a minus 6bt, 2a minus 6bt is equal to 0. So 6bt is equal to 2a. This and this will cancel. I get 3 out here. So t here will be a by 3b. That is the answer. Okay, now you have this question. The second exercise, a particle moves along a straight line such that its displacement at any time t is given by this. So this is the expression for the displacement, and the displacement is in meters. The velocity when the acceleration is 0. So we have to find what is the expression for velocity when the acceleration is 0. So from here what we need to do is we need to find both velocity and acceleration, just like we did in the previous problem. So how do we do that? Let us write down the expression for the displacement first of all. So this will be t cube minus 6t square minus 3t. So therefore velocity here is rate of change of displacement, so ds by dt. So if you differentiate this, you will get 3t square minus you'll get here 12t minus 3. So this is the expression for the velocity. And acceleration is dv dt. Okay, so if you differentiate acceleration, if you differentiate velocity, you differentiate this term, so you'll get 2 into 3 will be 660 minus 12. Okay, so here we have to first find the time, all right, since the question says when the acceleration is 0. So let us equate acceleration to be 0, and from there we will find the time. So 6t minus 12 is equal to 0. So 6t is equal to 12. Therefore, t here will be 2 seconds. So that means the acceleration is 0 at what time? At time 2 seconds. So let us put at exactly 2 seconds what will be the velocity. So therefore, velocity at 2 seconds is what is v, which is equal to 3. Let us put here in the expression for the velocity, instead of t we write 2. So we have 2 square minus 12 2 minus 3. So we have 3 into 4 minus 24 minus 3. 3 4 is 12 minus 24 minus 3. So we will get a negative. So 12 minus 24 is minus 12. Minus 12 minus 3. That will be minus 15 meter per second. That is the answer. Okay, let me just check once again. Velocity 3 t squared, that's correct, minus 12t minus 3, that's correct. Acceleration is 60 minus 12, that's correct. So acceleration 2 seconds. So this will be 3 4s are 12 minus 12 2 24 minus 3. So that will be 12 minus 24. So 12 minus 24 is minus 12 minus 12 minus 3 minus 15. Okay, that's correct. Okay, the next exercise, the velocity of a body depends on time according to the equation v is equal to 20 plus 0.1 t square. The body has, what is the correct option out here? So you can see here all the options are talking about acceleration. Okay, acceleration. Even retardation is an acceleration, but in the negative direction. Okay, so that means that from this expression of velocity, we have to find the acceleration, and that's very simple. How do we do that? Let us just differentiate this and we will get the acceleration. Let us write down velocity here, 20 plus 0.1 t square. So therefore, acceleration, which is dv dt. dv dt, so if you differentiate 20, you will get 0. Plus the 0.1 will come out. So differentiate t square, you get 2t. Okay, so acceleration here is 2 into 0.1, 0.2 times t, right? So now let us see whether the acceleration is uniform or not. Is it uniform? Yes, of course, the acceleration is uniform. Why? Since a is directly proportional to the time. So that means as the time increases, the acceleration also will increase. Okay. Is it a retardation? No. Why? Because there is no minus sign out here. And obviously, it is not a non-uniform acceleration. So which is the correct option? This is the correct option. Is it zero acceleration? Obviously, it is not equal to 0, right? So it is a uniform acceleration. Let's go to the next exercise. A particle located at x equals 0 at time t equals 0. X equals 0 means the origin. That means in the beginning, okay, before the particle starts moving, it was at the origin. It starts moving along the positive x direction with a velocity v, which varies as v is equal to alpha root x, where alpha here is a constant. Then velocity of the particle varies with time t as what? What is the okay, let me read the question nicely. A particle located at x equals 0 at time t equals 0 starts moving in the positive x direction with velocity v, okay, which varies as v is this. Okay, then velocity of the particle varies. Is it velocity of the particle? then velocity of the particle varies with time as what? Okay, let us do it. Okay, so here we can see that the velocity is given in terms of x, the position. Now we want the velocity in terms of time. Okay, so v is equal to alpha root x. But what is v? V is not the rate of change of position, or dx dt? Yes, that is the value of v, is it not? Root x. Okay, since v is dx dt. Okay, so from here let's take dt. This dt, if we take it this side, alpha will go down. So this alpha will be what? Will be, or what I can do here is alpha, no, this will be, let me do one thing. Let me do like this. Let me not, okay, let me take this dt that side and dx this side. Okay, so this will be dx by root x is equal to alpha dt. I think that makes sense. Okay, and I'm going to write this on the left side. On the right side doesn't matter. So this will be, actually x here is root, that means it is to the power half. Can I do that? Instead of root x, I will write x to the power half, and if I take this half up, it'll be x to the power minus half dx is equal to alpha dt. Okay, now what do? We will integrate. Let us integrate, integrating both sides. So integrating both sides, you will have x to the power half dx is equal to, alpha is a constant, it will go outside, dt. So what will be the limit of integration? Okay, it is starting from the 0, from the origin, so x to a position x, so from 0 to x, and here from 0 time to a position, to a time t. So this will be what? What is x to the power half dx? You remember the when we integrate, this power will increase by 1 divided by the new power, right? So this will be x to the power half plus 1, half plus 1 divided by half plus 1. This will go from 0 to x. Alpha, this will simply be t minus 0. Alright, so if you have not understood integration, then please go back and check the video for the integration, and you will be able to do this problem. Otherwise, if you can't do integration, then this problem you'll have to leave. Okay, I don't suggest you to leave, but you please understand the integration first. So this will be x to the power how much? Half plus 1 is 3 by 2. 3 by 2 divided by 3 by 2. Okay, from x, from 0 to x is equal to alpha t. So this, now what do we do? Instead of this x, we'll put with this minus 0. So this on the left hand side, it will be simply this value only, x to the power 3 by 2 divided by 3 by 2 is equal to alpha t. Got it? So here we want to find the time, right? Let us find the value of x out here. Let us find the value of root x. Okay, because we wanted to find this so that we will get the expression for velocity. Okay, so here x to the power half is actually what? Is it not, shall I do like this? Yeah, so instead of 3 by 2, let me write 1 plus half, and that would be better. 1 plus half. So this is actually x to the power 1 into x to the power half into root x. Okay, by 3 by 2. So this will be 2 by 3 is equal to alpha t. So what is root x? Root x will be alpha t. This will be 3. This will be 2 by x. Okay. That'd be right. I think I made a mistake out here. Please go back to this one. This is x to the power minus half. You see, x to the power minus half. I forgot to put the minus sign out here. So this will be minus half plus 1 minus half plus 1, so that'll be 1 minus half, so that'll be half. This also will be half. That'll be half. Okay, so this page I'll get x to the power half by half is equal to alpha t. So half will go that side, so root x is equal to half alpha t. So therefore velocity is equal to what? What was the expression for velocity in the beginning? This one, alpha root x. So instead of root x, let us put with this one. So velocity is alpha root x. So this will be alpha root x is this, half alpha t. So you get half alpha square t, right? So therefore v is directly proportional to t, which is the correct option. Correct option would be first option, this one, on height, this one. Exercise 5. A body is moving according to the equation, this equation, x is equal to this. All right, so because it is x, so this is the position. Then it's instantaneous speed. So this is not a very difficult problem. So instantaneous speed will just be dx dt. Finish. So you'll get a plus 2bt minus 3ct square. Answer. That's it. Okay, so let us do only those problems for now. Yeah, so we will do constant acceleration and free fall in the next video. Thank you.